Hello everyone, today we'll be discussing the problem transfusion chain which came in Starters 95 happened on 21st June 2023. The problem statement goes like, in living donation, the following blood types are compatible. A donors can donate to recipients of with blood type A and AB. B can donate to B and B. AB. AB can only donate to AB, and O are universal donors who can donate to A, B, AB as well as O. There are n peoples in a hospital where the blood type of the ith person is denoted by Bi. Note that Bi can be A, B, AB or O only. A chain is formed when a donor can donate blood to a recipient, who in turn can donate blood to another recipient, and so on. Find the maximum number of people that can form a chain of blood transfusions. The question states that if you have a blood type A, you can donate to A and AB. Okay. If you have blood type B, then this becomes B and AB. But if you have a blood type AB, you can only donate to AB. And if you have a blood type of O, you can donate to anybody else. Okay. So if we are given a tree, let us assume that the first test case was ABA. Let's create a tree such that A donates to A, vice versa. This is a bidirectional line, and another node is B. The longest transfusion chain is of length 2, that we can see that it is here. If there would have been another AB, then this would look like AB. So this, since this is not bidirectional, we can't count this as one chain. So one of the chain would have been of length 3 and another one would have been of length 2. Moreover, if there was an O, then there would be a bidirectional line like this. Okay, sorry, not a bidirectional line. There is a line like this, right? Now the longest chain would be of length 4 and length 3. Now the how are we adding a new blood type into a already existing chain gives us the answer. All the A's form one chain and all the B's let us assume that all the A's form one chain and all the B's form another chain. They can't be connected. That let us say that small a denote the number of A's and small b denote number of people with blood group B. They can't be connected. This divides the transfusion chain. If we have an AB, we can add it to both of them, and if we have an O, we can add it to both of them as well. Okay, since AB are terminating, we can always add it at the end of the chain and increase the length of the chain. And since O is generating, we can always add O in the beginning of the chain. Makes sense, right? So the question is asking that what is the longest length of the chain that is formed between the patients given. as by now I hope that most of you have figured out that the number of A's, the number of people with blood group A, O, B is one, A, O, A, B is one chain, and the number of people with blood group B, A, B, and O is another chain. We count both the number of, we count the length of both the type of chains and print which one is bigger. This is the C++ implementation of the solution that I suggested. I have taken the number of test cases as input. A is the number of the length of the transfusion chain depending on the people having blood group A, and B is the length of the transfusion chain depending on the people with blood group B. I have taken the number of people as input. If the person has a blood group A, B, or O, I increase one transfusion length of one transfusion chain, and vice versa the other transfusion chain, and return the maximum of both of them. I hope that I was able to convey the solution of my problem in a proper manner. If you have any doubts, you can always reach out to us in the comment section. Thank you.